The foundational layer of this nightly transformation is the sheer alteration of the sensory playing field. A shift so profound it creates what researchers term temporal niche partitioning. Sunlight, with its broad spectrum, is a democratizing force, allowing a vast array of species to utilize vision. But moonlight is a trickle of photons compared to the solar deluge. This isn't just dimmer light, it's a fundamental change in information availability. Creatures that rule the day are often rendered blind, clumsy, and vulnerable. This is the catalyst for the first societal shift, the rise of the hearing-dominant and chemical-dominant kingdoms. Data from the Smithsonian Tropical Research Institute in Panama shows that nearly 85% of mammalian activity in a lowland rainforest shifts entirely between diurnal and nocturnal guilds. The daytime canopy of chirping birds, visually hunting monkeys, and sunbasking reptiles gives way, but not to emptiness, to a meticulously organized takeover. The primary actors here are the gleaners and the whisperers, an entire class of predators, like the woolly false vampire bat, has evolved to hunt not by sight, but by listening for the precise rustle of a beetle larva, chewing inside a dead leaf, or the delicate footfall of a katydid on a twig. This hunting is so precise, it relies on a computational auditory map of the forest floor, built from returning echoes, that is arguably more detailed than any visual map a day creature could make. Concurrently, the realm of scent expands exponentially, with reduced ultraviolet photodegradation breaking down over plumes at night. Chemical signals become more persistent and travel further. A study published in Science tracked the pheromone trails of giant silk moths, finding that males could detect a single female's chemical call from over 7 miles away, navigating a turbulent, three-dimensional odor landscape that is as real and complex as a highway system. This sensory shift is the first rule of the night. The world is redefined not by light, but by sound and molecule. The floor of the jungle becomes a substrate of seismic communication. Numerous species of frogs don't just croak into the air. They vibrate the very ground through specialized sacs, sending coded messages about territory and mating that travel through the soil, bypassing the noisy airwaves entirely. Even plants are active participants in this sensory war. Many species, like certain night-blooming jasmine, time their scent release to peak lunar illumination, hijacking the moth navigation system to ensure pollination, while others increase nectar production specifically for bats, engaging in a biological trade agreement, food for seed dispersal. This isn't passive scenery. It's an active, bustling economy of information and energy exchange, operating on channels invisible to the human eye. The initial quiet you perceive is an illusion. You are simply tuned to the wrong frequency. The jungle is louder, smellier, and more electrically alive at night than during the day. But our human senses are blunt instruments, failing to decode the torrent of data flowing through the darkness. The moonlight is merely the key that unlocks this parallel dimension, the soft switch that tells one world to power down another, far more ancient and secretive, to boot up. Every rustle you dismiss is a deliberate signal. Every faint scent is a broadcast. Every patch of shadow is a strategic ambush point in a game with life and death stakes. This complex sensory tapestry sets the stage for the specific, brutal conflicts that define the moonlit hours, conflicts that are less about random predation and more about calculated, strategic warfare between entire taxonomic empires. If the first layer is the communication network, the second is the relentless, multi-front warfare it facilitates, and the most intense theater of this conflict is the vertical world of the canopy. By day, the canopy is a bustling city of leaves, competing for sunlight. By night, it transforms into a silent, hyper-competitive marketplace for space and nutrients, governed by alliances and enmities that would put any political intrigue to shame. The primary currency here is not light, but real estate and chemical defense. This is the kingdom of the epiphytes, the orchids, bromeliads, and ferns that live on tree branches, and the most shocking data reveals they are not mere decorative guests. They are aggressive settlers, chemical engineers, and manipulators. Research from the University of Utah, utilizing isotopic tracing, has shown that certain canopy fungi form vast, interconnected mycelial networks, a wood wide web, that can redistribute nutrients from decaying matter on one tree to a struggling seedling on another. But for a price. This network isn't altruistic, it's a controlled economy. The fungal hubs can preferentially supply allies or starve competitors, effectively deciding which plants thrive. Furthermore, many of these epiphytes and their fungal partners engage in biochemical warfare. They exude allelopathic compounds that rain down in the dew, inhibiting the seed germination of potential competitor plants on the forest floor below, literally poisoning the ground to protect their aerial territory. But the warfare isn't just plant on plant. This dense, vertical architecture becomes the battleground for aerial acrobatics of staggering precision. Neotropical fishing bats, like the greater bulldog bat, don't just scoop fish from water. They use the moon's gleam on water surfaces to detect the minute ripples made by fish, employing echolocation so advanced it can distinguish between a rising bubble and a fish's fin breaking the surface. Their hunting success rate plummets on moonless nights, proving their dependence on that faint celestial glint. Meanwhile, in the same airspace, rival bat colonies engage in jamming signals. Studies of Mexican free-tailed bats show that when competing colonies forage in overlapping zones, they will actively emit feeding buzz echolocation calls outside their own hunting frequency to confuse and disrupt the sonar of rivals. A clear act of biological signal jamming. This is economic sabotage in the acoustic realm. Simultaneously, the insect world erupts. Moths, the primary prey of bats, have evolved not just passive defenses but active countermeasures. Many have developed ears tuned specifically to the echolocation frequencies of their local bat predators. Upon hearing the incoming sonar ping, they don't just freeze. They perform evasive dives, loop-the-loops, or even emit their own ultrasonic clicks that jam the bat's sonar by startling it or blurring the returning echo. This is a co-evolutionary arms race happening millions of times every night, an ancient dogfight with survival as the only trophy. And presiding over this vertical chaos are the apex arbiters, the nocturnal birds of prey. Spectacled owls and mottled owls operate as silent, feathered spec ops teams. Their wing feathers are serrated to eliminate aerodynamic noise, granting them acoustic invisibility. They hunt not just by exceptional low-light vision, but by integrating auditory maps with such precision that they can strike a rodent moving under a thick layer of leaf litter, guided solely by sound. Their presence imposes a top-down pressure that shapes the behavior of every creature below, from the cautious foraging route of a kinkajou to the frozen posture of a tree frog. This multi-layered conflict chemical, acoustic, and predatory creates a dynamic equilibrium, a fragile peace enforced by constant calculated violence. The moonlight here isn't a romantic backdrop. It's the operational lighting for the most sophisticated and ruthless stock exchange on the planet, where the commodities are life, space, and genetic legacy. While the canopy is a zone of aerial and chemical conflict, the forest floor beneath the dappled moonlight becomes a stage for a different, more primal drama, the theater of decomposition and resurrection, a cycle so vital it underpins the entire jungle's existence. This is where life is most visibly recycled, and the agents of this process are not mere cleaners. They are sophisticated, organized guilds that work in shifts with an efficiency that would humble any waste management corporation. The initial actors on a freshly fallen fruit or deceased animal are the necrophilous insects drawn by volatile organic compounds released within minutes of death. Carrion beetles, using antennae sensitive to parts per billion concentrations of putrescine and cadaverine, arrive with an eerie sense of purpose. But the data reveals a shocking hierarchy. Not all carrion beetles are equal. Research from the Brazilian Amazon cataloged a strict succession pattern. Large, powerful beetles like dichotomous species arrive first, capable of burying small carcasses entirely to sequester them from competitors. They are followed by specialist mites that hitch rides on the beetles, not as parasites, but as fellow decomposers targeting different tissue types. This isn't chaos, it's a scheduled, multi-species dismantling crew. As the beetles work, the chemical signature changes, attracting a second wave, flies. Their maggots operate as external digestive systems, secreting enzymes that liquefy tissue, fundamentally altering the biochemical landscape of the carcass. This activity, in turn, heats up the microenvironment. A maggot mass can be 20 degrees Celsius warmer than the surrounding air, creating a thermal hotspot that attracts a third wave of heat-loving insects and nematodes. But the true architects of the forest floor are the fungi and the untold billions of microorganisms. Mycelial networks, the vegetative part of fungi, are the internet of the soil. They don't just decompose, they communicate through the release of electrical and chemical signals. They can warn neighboring networks of an incoming threat, like a swarm of grazers, or direct resources to areas under stress. They form mycorrhizal symbioses with over 90% of terrestrial plants, trading soil minerals for plant sugars in a barter system that has existed for over 400 million years. This fungal network also has a dark side. It can be predatory. Carnivorous fungi like set microscopic snares that constrict around nematode worms, digesting them for nitrogen, a literal underground landmine field. Meanwhile, the animal kingdom contributes to this cycle through bioturbation, the mixing of soil. Giant earthworms in these ecosystems, some reaching several feet in length, are not simple burrowers. They are ecosystem engineers. Their continuous tunneling aerates the compact soil, dramatically increasing water infiltration and creating channels for root growth. Their castings, excrement, are supercharged with bioavailable nutrients, creating fertile hotspots known as droop sites, where seedling density is markedly higher. The moonlit floor is thus a vast, living digestive system. Every fallen leaf, every deceased creature, is instantly enrolled in a frenzied, competitive, yet beautifully coordinated process of deconstruction and redistribution. The nutrients released tonight in one spot will be taken up by a nearby root tomorrow, transferred to a leaf, eaten by an insect, and passed up the food chain in a continuous luminous loop. The beauty of a moonbeam highlighting a decaying log is, in data-driven reality, a spotlight on the most critical and relentless recycling plant on Earth, where death is not an end, but the most active and collaborative phase of existence. Beyond the immediate conflicts of predation and decomposition lies perhaps the most profound and overlooked aspect of the moonlit jungle, its role as a global climate regulator and hydrological engine. This function operates on a macro scale, directly influenced by the microactivities of the night. The data here connects the chirp of a frog to the rainfall patterns of entire continents. It begins with transpiration. During the day, plants actively open their stomata to take in carbon dioxide, losing vast amounts of water vapor. In the process, a process that powers the biotic pump theory of atmospheric circulation. But at night, a significant and previously underestimated phase occurs: foliar uptake and nocturnal transpiration. Many canopy plants, through specialized leaf structures, can actively absorb moisture from the night air, a crucial hydration strategy in the dry season. Simultaneously, some trees continue a baseline level of transpiration at night, releasing water vapor that contributes to the formation of the characteristic pre-dawn mist that shrouds tropical forests. This mist is not just atmosphere, it is a critical component of the forest water cycle, reducing evaporation stress on understory plants and contributing to localized precipitation. The jungle, in essence, makes its own weather every single night. This moisture, combined with the complex topography and the heat retained by the massive biomass of the forest, creates persistent low-pressure zones. These zones act like gigantic atmospheric siphons, drawing moist air from the oceans inland. Research models have shown that large, contiguous forests like the Amazon are responsible for generating flying rivers, vast aerial currents of water vapor that travel thousands of miles. The health of the nocturnal processes the fungal networks moving water, the roots actively drawing from deep aquifers, the continuous, low-level respiratory gas exchange of millions of leaves directly influences the volume and consistency of these flying rivers. Disrupt the night cycle by deforestation and you don't just lose trees, you break the pump. Data from the Amazon shows a clear correlation between deforestation rates and decreased downwind rainfall, leading to desertification in regions thousands of kilometers away. Furthermore, the moonlit jungle is a massive carbon sink, and its nighttime respiration is a key part of that equation. While photosynthesis ceases, respiration continues. The soil itself breathes out CO2 from root and microbial activity. This efflux is a major component of the global carbon cycle. Critically, a healthy, biodiverse forest with a complex structure regulates this respiration more efficiently. The very predation and decomposition we've detailed ensure a balanced, slow release of stored carbon. A degraded forest, with broken nutrient cycles and simplified food webs, can tip from being a sink to a source, releasing catastrophic amounts of stored carbon. The moon, therefore, illuminates not just a scene of life and death, but the very machinery of planetary regulation. Every bat controlling an insect population that would otherwise defoliate a tree. Every earthworm aerating soil for a root system that anchors tons of carbon. Every fungal network redistributing resources to keep the forest resilient. These are not isolated events. They are the active, nightly maintenance of a climate-stabilizing engine. The jungle at night is Earth's life support system, running its graveyard shift, performing essential diagnostics and repairs to ensure the system is functional for the day shift. When you look at that moonlit canopy, you are looking at the lungs, the kidneys, and the circulatory system of our living planet, performing its most critical functions under the cover of darkness. Having journeyed from sensory shifts to global climate systems, we arrive at the final, humbling truth. The moonlit jungle is a mirror held up to human civilization, revealing both our profound connection and our catastrophic disconnection. The intricate economies, communication networks, warfare, and recycling systems we've detailed are not mere biological curiosities. They are blueprints for sustainability, models of resilience honed over hundreds of millions of years. Consider the waste management system on the forest floor, a zero-waste, circular economy where every output is an input for another. Contrast this with our linear take-make-dispose model that creates landfills and ocean gyres of plastic. Consider the chemical communication network, a precise, targeted messaging system that leaves no physical waste versus our bombardment of the environment with radio waves and light pollution that disrupts these very animal networks. The jungle's energy grid is decentralized, solar-powered, and hyper-efficient, stored in chemical bonds and redistributed through mutualistic trade. Our energy grids are often centralized, reliant on extracting and burning fossilized past ecosystems, creating pollution and geopolitical conflict. The most shocking data of all comes from the frontier of biomimicry and ecosystem valuation. Scientists attempting to price the ecosystem services provided by a healthy rainforest, carbon sequestration, water purification, air generation, soil formation, pollination, disease regulation consistently arrive at astronomical figures, often in the trillions of dollars annually for major biomes like the Amazon. These services are performed for free every second, with moonlight as the only witness. Yet we value the short-term profit from its destruction, the timber, the cattle pasture, the monoculture farmland at a fraction of that amount. This is the ultimate cognitive dissonance. We are actively dismantling, for pennies on the dollar, the most sophisticated life support system ever devised, one that we do not have the technology or wisdom to replicate. Our incursion into the night is particularly damaging. Artificial light at night is a growing pollutant that fragments this ancient world. It disorients migratory birds, fatally attracts insects, alters predator-prey dynamics by giving visual hunters an unfair advantage, and disrupts the reproductive cycles of plants and animals that rely on lunar cues. A study in Nature showed that in artificially lit areas, the special night pollinator visits to plants drop by over 60%, directly impacting fruit set and ecosystem health. The moonlit jungle, therefore, stands as the ultimate benchmark for a functioning society. It shows that true advancement isn't about dominating nature, but about integrating complexity, fostering mutualism, operating on circular principles, and respecting the ancient rhythms set by celestial cycles. Our survival as a species may well depend not on conquering these wild spaces, but on learning to listen to their moonlit lessons. To witness this world is to understand that intelligence is not a monopoly of the human brain. It is embedded in the structure of a fungal network, the echolocation algorithm of a bat, and the chemical lexicon of a tree. We are not separate from this system. We are a part of it. And our current path of disruption is not just an environmental error, but a profound failure to understand the system of which we are a member. The final, stark revelation of the data is this: the jungle at night doesn't need us, but we unequivocally need the jungle and the complex, invisible work it does under the moon's watch. This journey through a single moonlit night changes everything. It's not just about appreciating beauty, it's about understanding the machinery of our planet. If this data-driven deep dive resonated with you, if it shifted your perspective even a fraction, then your role begins now. First, make your support tangible. Smash that like button with the force of a carrion beetle bearing its prize. It tells the algorithm this in-depth content matters. Subscribe if you haven't, because we're just getting started. The next video will deconstruct the intelligence of coral reefs with the same data-driven intensity. Ring the bell to ensure you're notified, but don't let it end here. Become an ambassador for the night. Share this video with one person who thinks nature is just a pretty picture. Comment below with the one fact that shocked you the most. Let's build a community of the curious and the informed. Turn off unnecessary outdoor lights to reduce light pollution. Support organizations that purchase and protect old-growth forest tracts. The data is clear, the story is urgent, and the time to act is now. The moon will shine on the jungle tonight. The question is, will we be wise enough to ensure it still has a jungle to illuminate? Your click, your share, your choice matters. Be part of the shift.